Hello everyone, welcome back to my YouTube channel. So today we are going to discuss something related to the bar bending schedule of a simple beam. So here I have listed some data regarding this. So this diagram is basically representing all the things. Like you can see that the width of support is 300 mm, that is the column size is, or column width is 300 mm. Then the width of or length of your beam is 3 meter, and all this data is given to you. Only we need to calculate the bar bending schedule. So there are some steps involved in this procedure, how we are going to calculate it. So basically this is what is the width of like width and depth of your width and depth of beam. Okay, so clear span of beam is 3 meter, development length is LD is equals to 50D, we are going to assume it like that. Then clear cover is 25 mm. So the very first step based upon this all data is cutting length of top bar, because while you are demanding, or while you are going to uh, we can say whatever the quantity of steel we required on the site, so length of bar should be in one single length, um, because we cannot purchase it in like we can say pieces. Yeah, so we cannot purchase it in pieces, we have to like purchase it in one single length. So how much length of bar we want to we can purchase for the site, or we required for the site, that we are going to calculate. So for basically the cutting length of top bar is clear span of the beam plus development length on two sides minus clear cover on both sides, that will be the cutting length. So 3000 is the total length of beam plus 2 into 50D minus 2 into 25, that is the clear cover on both sides. So the result comes out to be 4150 mm. Okay. Then the second one is step 2, cutting length of bottom bar. Okay, so cutting length of bottom bar is 3000 plus in bracket 2 into 50D minus 2 into 25. So the results are same data you have to put that as that of your top bar. So only what will change is what here is going to change the diameter of bottom bar, because sometimes it may happens that your top bar diameter and bottom bar diameter can be a different one, so that's why it will change. So it approximately changes, and the value comes out to be 4550 mm. Then the next is third step, that is number of stirrups. First we need to calculate. So clear span of the beam divided by spacing of stirrup plus 1 is mandatory for it. Then we come out to the conclusion that the value comes out to be 21 number of stirrups will be required for the total length of beam, that is 3 meter. So the step 4 is cutting length of stirrup. So to calculate the cutting length of stirrup, I have drawn one figure to understand this clearly. That is, we are going to assume that the A will be the width of beam and B will be the depth of beam. So 3 are 90-degree bends. So these 3 are 90-degree bend, and one is hook. So hooks are one this and one this, that is 2 hooks are provided to this. So based upon this, length of one hook will be 9D, we are going to assume it. Then cutting length of stirrup for this perimeter of stirrup plus number of bends plus number of hook. Okay, so 2 into A plus B, that will be the perimeter, plus 3 into 2D, that will be the number of bends. So number of bends are 3, so 3 into 2 into D plus 2 into 9D, that is the number of hooks. For one hook 9D, how many hooks are there? 2, so 2 into 9D. Okay, so value comes out to be 1792, that is 1.792 meter. Step 5 is total number of stirrups, 21. Length of stirrup, to calculate it, you have to multiply it with length of one stirrup multiplied by number of stirrups. So you will get the length of stirrups. Then weight of stirrup, to calculate it, you know one formula, that is phi square divided by 162 into L. So by putting values in this particular formula, you will get the result, that is something approximately 14.86 is the value, that is of weight of stirrup. So you can put all the dimensions or whatever the results you get in one column or one table. So this table will represent everything, that is bars, dia, numbers, cutting length and total length. So whatever the result you got from that calculation, you just have to put it in that format. Okay, so this is the very simple calculation we have learned. So in my coming video I am also going to clear the data, or we can say we will discuss the bar bending schedule for a continuous beam. Okay, so thank you. If you like my video, please like, share and subscribe my channel. Thank you guys.